Hey everybody, welcome back to Mass Office Hours. My name's Eric Trexler from the Mass Research Review. Normally, I host these live every single Wednesday night with one of my colleagues from the Mass Research Review. Tonight, we could not do it live due to schedule constraints, but nonetheless, we have a fantastic episode for you tonight. What we're doing is airing an audio discussion of a previous Mass article. So every month, in the Mass Research Review, we write a number of articles. Some of them are full-length articles. Some of them are research briefs. We even have some video lectures in there. So if you're not a subscriber to the Mass Research Review, tonight you're going to get a little sneak peek into what a tiny portion of that content actually looks or sounds like. So back a few issues ago, Dr. Eric Helms wrote our cover story, and the title was, "Can You Stay Shredded?" And tonight's episode is going to be the audio discussion that he and I had about that article when it came out. So I'm just going to go ahead and read the little blurb that explains what this article is all about and subsequently what tonight's episode will be all about. In the fitness industry, many claim that with their system, supplement, or coaching, you can have your lean dream body 24/7. While some get really lean, few, including bodybuilders, maintain a shredded physique year-round. So why is this? Are there inevitable physiological consequences that make it very difficult to stay very lean? Or are people just doing it wrong? Another way of considering that is it really, are these challenges really driven by low body fat? Or is it just that people are not approaching their diet or their exercise the right way? Is it low calories or low body fat that makes it so challenging to stay lean in the long term? In this discussion, we dig into all of these questions and more. It's very in-depth. It runs about 45 minutes, give or take, and we think you're really going to enjoy it. So thanks so much for joining us for another episode of Mass Office Hours, and we will be back live next Wednesday night with another episode.
So for this month, I actually wrote the cover story, which was an honor to do. And I wrote it specifically on the question that many ask in the fitness industry: can you stay shredded? Now, this is one of those questions that I think people probably have a default and knee-jerk response to, and it will largely be dictated by personal experience. If you're someone who is naturally lean, you know, we all know a few people like that who's just kind of always walked around at something approximating, something close to contest condition that most and the vast majority of people would have to diet to get to. You might think, yeah, sure, I don't even think about it. I'm just one of those people. If you run in certain circles, if you compete in a high-level sport or you coach people at a high-level sport, especially certain sports which seem to select for being leaner, and that helps performance, you're going to be exposed to that more frequently. But on the other hand, if you're someone who works in, say, a personal training facility or a weight loss clinic, or you work in public health, or you kind of live just an everyday life, or if you work with bodybuilders and you see that most people have to actually diet and they have to do a contest prep, not just buy posing trunks, you would think the opposite. But of course, here at Mass, we don't just answer questions like this by going on what do we anecdotally notice. We try to answer this question in depth. And this is a question that a lot of people are interested in. It's not uncommon at all for people to claim in the fitness industry that with their coaching or their book or their system, or sometimes even with supplements, that if you take it, it'll result in you being able to maintain with ease your dream body 24/7, or sometimes in a much more honest sell. If you work really hard, you diet, and then we do these certain things once the diet is over, you can maintain a really, really lean physique. So obviously this question is for people who have to get lean first to then maintain it. Because if you do happen to be one of those people who already is walking around shredded, congratulations. But, the question is have you done something? Have you stumbled upon this? Or is this an innate trait of your genetic characteristics? Or have you stumbled onto a certain set of behaviors and environment that allows you to do this, that is therefore replicable in other people? And many marketers in the fitness industry would suggest that it actually is that if you just did things right, you would be able to maintain a lean physique. And not only that, but you would look like the people on the covers of these ads or in these pictures, smiling, happy, incidentally surrounded by other attractive people and expensive things, this is going to be great. And that conflicts with the experiences that most bodybuilders like myself and coaches will share, and that getting shredded takes a lot of work. It's certainly possible. Indeed, anyone can get shredded, I would argue, whether you maintain muscle or are happy getting there, and then whether you can maintain that state of being without it having negative effects that aren't worth it is the real question. Because if we wanted to talk just pure theory or just pure kind of quantitative thinking and not thinking about the qualitative experience of getting shredded and staying there, sure, anybody can get shredded and stay shredded. If you were given a 1,200 calorie meal plan that was delivered to you and locked in a room, most people, unless they were very small and burned very few calories, would get shredded and then stay there. They might have poor health, they might hate their life, etc. But could you stay shredded? Of course. So the real question is, I think that we're trying to get at, is can you stay shredded and have it be worth it? And of course, that again is also subjective, but there are some ways we can try to answer this question. And in my article, I approach them. And to really answer this question, I had to delve into a number of different related but distinct areas of research, which intriguingly, and I always love this when I dive into research, you'll find different lines of research that are similar, are sometimes dissimilar enough that they actually are not really aware of each other's fundamental lines of research. They don't cite some of the first most seminal works that were done in an area, and they don't consider each other's paradigms. So it is sometimes quite illuminating when you read these divergent but similar lines of research to see what's missing and what can link the two. And that's essentially what I tried to do with this article. And I started with a topic that we've discussed in mass, but that is probably less familiar to your typical evidence-based body composition interested person in kind of the pop science sphere. And that is energy availability and what's called REDS, relative energy deficiency in sport. Now, I would like to say that this is less familiar to most people in our space simply because it's a newer topic. I think the first position stand on REDS and low energy availability that was adopted by some of the larger sports science organizations came out in 2014. And then the most updated one I saw was 2018. So we're talking about, statements that have only been accepted at kind of the organizational level as consensus for less than a decade. Although the research does go back into the mid-2000s if you look at what led to the understanding of these topics. So it could be that you could make that argument, and I wouldn't totally disagree with you. But I honestly think it has more to do with the fact of what are people interested in? And they're interested in getting really lean and the quantitative aspects of that if we're talking about kind of evidence-based bodybuilding. So that's why our focus, instead of on energy availability or REDS, has typically been on metabolic adaptation, or probably better coined adaptive thermogenesis, and thinking about the numbers related to that. When I diet, how much does energy expenditure go down? How do I maintain my deficit? And then how can I go about the process of getting very lean? That's kind of the focus, understandably, of the research that we're interested in, because that's what we're trying to accomplish. However, energy availability in REDS is much more to do with what are the symptoms that affect health and performance in athletes and people who exercise when they go through the process of not eating sufficient energy to allow their bodies to have full physiological function. And that is essentially describing the same phenomenon, but from a different lens. So to back up, energy availability is not something most people are familiar with, and when they hear it, they'll most often think I'm talking about energy balance, okay? So when you hear low or high energy availability, you might substitute that in your mind as saying a large deficit or being in a surplus. But they're actually distinct things, although they often co-vary. So first, energy availability is actually mathematically calculable, and it is simply the amount of energy that you're taking in relative to your lean body mass after subtracting your exercise activity expenditure. And that basically represents how much energy is left over after exercise for physiological function. And there's been a fair amount of research on this going back almost 20 years that finds there tend to be some regions or thresholds where going too low results in symptoms that we associate with contest prep feeling shitty in the bodybuilding community. The negative experiences of trying to get really, really lean. Low energy, feeling worse, the hormonal adaptations, drops in testosterone, amenorrhea, ghrelin going up, leptin going down, all the good stuff that we think of that is associated with dieting that makes it just a miserable experience for most people. That is also the symptoms of REDS. If you were to look at what describes REDS, which is relative energy deficiency in sport, which is caused by low energy availability, there's spokes on the wheel that have to do with effects on the immune system, menstrual function, bone health, endocrine function, your metabolic adaptations, which are probably the ones we're most familiar with, growth and development and psychological effects, and then effects on performance that are related to those systems. So energy availability is interesting because it kind of explains that the things we experience as contest prep bodybuilders are basically REDS. And when we understand that to get to the point of being really, really shredded, we need to have calories restricted, we need to be in a deficit, and that also results in low energy availability and eventually leads to REDS. So it's understandable why we would kind of see energy availability as a synonym for energy balance, but it's actually not. And indeed, you can be at energy balance and actually be in a state of low energy availability, specifically because of what we're more familiar with, the concept of adaptive thermogenesis. So what people are probably much more aware of is that there is well-documented evidence going back even longer than energy availability research started that shows that when someone loses substantial weight, especially if they go on a relatively aggressive diet, there's often what's called adaptive thermogenesis, which is simply the reduction in energy expenditure beyond what would be predicted by changes in body weight. And this comes from a multitude of adaptations in the body, making you more efficient when you move, which sounds good, but it's not. Basically meaning that we burn fewer calories for low-intensity activities. We fidget less. Non-exercise activity thermogenesis goes down. And there are also some small changes to actual BMR, our resting metabolic rate. And overall, if we look at kind of the averages in the research, when you look at reviews on this topic, you can expect someone who is dieted and lost a substantial amount of weight, say 10% of their body mass, to maybe burning, on average, about 15% less than you'd expect for total daily energy expenditure. So if you do the math and you think about, okay, if I was to start here, where I'm currently at, and get really lean for competition, if you had to lose around 10% of your body mass to do that, and therefore you're burning, on average, approximately 15% less calories than you expect for your body mass, your maintenance calories, and I actually did a calculation in this article, might be lower than some of the thresholds associated with low energy availability, eventually resulting in REDS. And so that's the connection between the two. And interestingly enough, if you read some of the seminal papers by Lukes and colleagues, Lukes is probably the most prolific researcher in the topic of energy availability, REDS, female athlete triad, and understanding the actual causes of why you see amenorrhea in women and athletes and why you see the female athlete triad. It all does come down to, based on her research, which she's done quite well and shown pretty conclusively, energy availability. Because, for example, you can cause amenorrhea by fasting women who are actually in a very high BMI category. They'd be classified as overweight or obese. So that's independent of how lean they are. And that is really the crux of the question that I've eventually come to here is, well, if we can't stay shredded, or if we can stay shredded, that would require us to focus on body fat. If we could somehow eat enough calories while being shredded, based upon the energy availability research, which has isolated the cause of REDS to simply how much are you eating relative to your body mass or your lean body mass and activity, independent of your body fat levels, then the answer would seemingly be, hey, theoretically, yes, you should be able to stay shredded if you can just eat enough. And even if you couldn't, that's just an indirect effect of, the adaptations you had to go through to get shredded. But it's actually not your body fat level that's the problem. It is the fact that you're not eating enough. And indeed, that is basically the argument that Lukes presents. She acknowledges that some of the physiological mechanisms that exist that seem to co-vary with body fat are there, like leptin, which I'll talk about. However, that they're actually just a sensor of energy availability, because indeed these hormonal signals do change based upon how much you're currently eating. So if you just stay in the REDS world, you would think, hey, if I could get shredded and then get my calories back up to a point where I was above a threshold for low energy availability, I'd be able to stay shredded. I'd feel fine. I wouldn't experience these symptoms, and I'd be able to perform well. On the other side of it, though, when we simply look at the metabolic adaptation research, there's a line of it that specifically looks at body fat set points. So the idea of a body fat set point is not foreign to the online space, if you've heard discussions about dieting. And the idea basically mirrors the first model that goes back to the 50s called the lipostatic model. And it says that, hey, your body fat levels in your body send signals to your brain telling you whether they're at, below, or above your set point, and then it modifies your behavior and your energy expenditure to drive you back towards it. It will get you to eat more or eat less, and it will increase or decrease your energy expenditure to drive you back towards your set point. And this was largely theoretical, and it met some of the anecdotal observations that existed at the time, pre-obesity epidemic, I'd point out, until the 90s, where they actually discovered leptin. And leptin, indeed, co-varies with the amount of body fat you have, and when you decrease body fat or increase body fat, those levels get lower or they get higher in proportion to the amount of body fat. So at this point, the lipostatic model became a little more than theory. It was thought, this is actually the way things operate. Unfortunately, though, there's some pretty big problems with the lipostatic model. Obviously, I mentioned the obesity epidemic. It doesn't explain it. It seems that humans are really poor at defending weight gain, but they are pretty good at defending weight loss. And this makes sense from a selection pressure, kind of an evolutionary biology perspective. We've had more threats as a species from famine than we have from predation. And you'll notice that in some animal models, like mice, which are prey animals, they seem pretty good at defending body weight both directions. Because you know what a big, fat, juicy, slow mouse is? That's an eaten mouse. And that's not as much of a threat to humans. We've had pointy sticks for a long time that pretty much anybody can use. And we're smart enough so that we're not prey animals. And more often than not, we're the hunters rather than the huntees. So anyway, that is at least the theoretical understanding of why perhaps we don't just have this simple lipostatic model. And indeed, when you look at leptin physiology, we see that it doesn't actually follow the lipostatic model in certain directions. For example, individuals with common obesity have very high leptin levels, but it's insufficient to prevent them from gaining more weight or maintaining a very high body mass. So the more accurate model that fits with the observations and that meets everything we've seen and that has been proposed in more recent times is what's called the dual intervention model. And it's basically the idea that we have 2 points, 2 different quote-unquote set points, if you will, that are dictated by physiology or more dictated by physiology. Our upper intervention point, where at that point, our body, once we try to go above it, starts to do things to increase energy expenditure and make us more satiated so that we don't keep gaining weight. And our lower intervention point, which does operate pretty similar to how the lipostatic model saw the defense of further weight loss. So the dual intervention model basically means that there's this range that is not regulated by your physiology primarily, but rather by your environment. And when I say environment, I mean that in very broad terms, whether or not you are dieting, whether or not you are exercising, what environmental cues you have, food availability, how active you are, all this stuff. Everything in between those 2 intervention points, that is a body weight or body fat range that is primarily influenced by those factors. And it is more modifiable for you with less effort than going above or below it. Trying to get extremely high in body fat, if, say a sumo wrestler was to try to push up their body weight, or trying to get really, really lean, say in the example of a bodybuilder, you get to certain points where your body will push back against you more. So, interestingly enough, you won't hear the REDS or low energy availability research talking about body fat set points, and you also won't hear the adaptive thermogenesis research talking about REDS. In fact, Eric, since you're here, I mean, how often are the studies on metabolic adaptation and in weight loss and in individuals with obesity, are they looking at interventions of very low calorie diet where they put people like immediately on liquid diets of 800 calories? And I guarantee you, if there's anyone involved with the low energy availability research on that research team, they'd say, no. Let's diet them on the highest calories we can, because we're not trying to induce this immediate low energy availability status and having them experience, symptoms of REDS. We don't need to do this. Why don't we go for a slower rate of weight loss? But it's pretty common in this literature to see like rapid weight loss strategies.
Oh yeah. I mean, it's, I would call it kind of the default, which is kind of funny because, you can, sometimes people tell on themselves a little bit when they're like, oh my God, like, you mentioned something about like a 1,200 calorie diet. I can't believe that someone would even consider possibly assigning that to someone. And it's like, have you ever read the weight loss literature? Like that's like the default approach, right? It's like 800, 1,100, 1,200 calories. But yeah, I mean, they do it all the time. And yeah, you kind of immediately just jump out to some of those adaptations.
Yeah, exactly. And it's an interesting thing, because then it makes you wonder, well, are a lot of the metabolic adaptations, adaptive thermogenesis things we're seeing, are they being exacerbated or happening earlier because of the methods? And I would argue probably. And I think that's a good way of looking at the connection between REDS and low energy availability and adaptive thermogenesis, is that adaptive thermogenesis attempts to quantify the reduction in energy expenditure that comes from the downregulation of physiology, and REDS qualitatively describes and also quantifies how that actually affects physiology. And it goes through, how that makes people feel, how it increases risk of injury in athletes in the status of low energy availability, how, you will see negative effects on reproductive function. So you'll see amenorrhea in women, you'll see low testosterone in men, you'll see knock-on effects in women on bone health, and you'll see various markers. And that's basically describing, hey, this is how it's affecting the person. And yeah, that's REDS, but adaptive thermogenesis is saying, yes, and that results in this type of reduction in energy expenditure. So they're really both describing the same thing. And I think once you can link those two, it becomes difficult to have a really firm position like some of the REDS researchers do, and maybe some of the voices in the community who are telling you that you can stay shredded, to think that it really has nothing to do with body fat, that it's just energy intake. And if you would, you get shredded, you bring your calories back up, you quote unquote reverse diet, you'll be fine. And the reason I say that is because it begs the question of, well, why does energy expenditure stay reduced in weight-reduced people? What's the deal? And this is true even sometimes years after the fact. There are studies by Rosenbaum and Liebel where they look at people and they compare folks who are, say, 10% weight reduced, who got there 1 to 2 months ago, versus those who did it over a year ago. And indeed, they actually have similar adaptive thermogenesis. It doesn't go away. Unfortunately, it persists. And that sounds really negative, and this is a bit of a tangent, but you'll also notice that adaptive thermogenesis co-varies with weight loss success. This is just kind of the process. And not everyone will have, say, a 15% reduction in energy expenditure, and not everyone will be able to, have, some people might have more, some people might have less, but it may persist until weight is regained. And that's not necessarily a death sentence. We see that is still something people can live with. But I do think it is certainly exacerbated if you immediately also go to an 800 calorie diet. So these things are happening in conjunction. And I think if we go back to leptin, which I described, we need to understand that it is a system that is multifaceted. When we look at actual leptin physiology, we see that there's receptors for leptin in most of the tissues in our body. It is secreted primarily from fat cells, but not exclusively. And indeed, the stomach secretes leptin. And there are acute changes in leptin in response to dietary choices, differences in macronutrients, the presence of an energy deficit and the magnitude of an energy deficit or surplus, even different food types. However, when we look at what dictates our baseline levels, what does our leptin level return to post-meal when we're not in the postprandial state, which is most of the day, that seems to be heavily influenced, indeed, by how much fat mass is on our bodies, to the tune of maybe a correlation of 0.85, so explaining more than 70% of the variation when we look at some of the largest population studies on this. I'm thinking of the study by Considine and colleagues, which I cite in the paper. They've got close to 300 participants in this study. About half of them are normal weight, half are with obesity, and they saw a 0.85 correlation between body fat percentage and serum leptin levels. So far and away, it is your fat mass which dictates your circulating resting leptin levels. Yes, that can be modified when you go into a deficit, and I think the way these two things will interact is that, okay, if you are someone who is above your lower intervention point and you start dieting, and you diet very aggressively, you can start to experience metabolic adaptation, low energy availability, and symptoms of REDS immediately, even if you're still in your, above your lower intervention point, because you've tanked your calories so low. However, that also indicates that if you were able to put yourself into a small deficit, stay in a status of adequate energy availability, but still in a deficit, then you might be able to lose fat mass without some of these negative effects. However, that also means that once you get to the point where you're bumping up against your lower intervention point, trying to diet further, you probably won't be able to do it without those circulating leptin levels dropping and you starting to experience some of those same symptoms of REDS and low energy availability, because those signals all do initiate from leptin. Not exclusively, in conjunction with others, but it is kind of that initial match that lights the fire, if you will. It's that initiator. So I think that's the way I tried to describe it in the article, and I think it does make sense. But I didn't just stop there. The final piece, after I connected REDS with adaptive thermogenesis and with the dual intervention model, was I said, hey, let's test this. We don't have to just take my word for it with the way I've connected these theories. I'm not just building a house of cards. I said, okay, let's blow some wind at this house of cards. Let's see if it actually can stand the test of observations and the data. And we do have some data that looks at this. So for example, if we were to say that, body fat did not matter and that it really just came down to how much food you were eating, we would expect there would be similar adaptations in people with obesity or people who are lean when they start dieting. But that's actually not the case. Eric, I think it was one of your research briefs you reviewed not too long ago. There was a meta-analysis that looked at dieting, or caloric restriction, I should say, and the effects of testosterone in men. And the meta-analysis reported that in those with overweight or obesity, there was actually an increase in testosterone in response to an energy restriction. However, in those of normal weight, there was a decrease in the majority of studies. So obviously, right there, we're starting to see that individuals with different body fat levels, when they start dieting, they seem to have seem to have divergent effects. Additionally,
yeah, that's correct.
Yeah, okay, cool. Glad to hear it. Additionally, there's a pretty well-established line of research just showing that individuals who are leaner are more likely to lose lean body mass when they start dieting. So you start to rely more on protein as a fuel, both from what you're eating as well as potentially from your body. As we see lean dieters, when they start dieting, they actually have increases in muscle protein breakdown in addition to a blunting of muscle protein synthesis, while in dieters or those who are in acute energy deficit who are higher in body fat just see that blunting of muscle protein synthesis. And that's probably why we see generally that people leaner tend to lose more muscle mass, or lean body mass, I should say, when dieting versus those higher in body fat. So dieting impacts people differently dependent upon body composition. And the even more direct evidence is the scant research we have looking at actual bodybuilding competitors who then attempt to do what's called, when you're probably familiar with, a reverse diet, which is just essentially a slow, conservative process of increasing calories and decreasing cardio to slowly come out of a deficit and basically try to minimize fat gain post-contest. Now, we don't have a lot of research on this, and the one piece of research I actually believe you were part of the analysis, Eric. So if I say anything out of turn, please let me know. But that was by That was by Longstrom out of Dr. Bill Campbell's lab. And they looked at, I want to say, about 9 competitors post-competition who went and they did their own thing post-contest. Some of them were trying to do reverse diets. Some of them succeeded. Some did not. Others were doing more aggressive type of quote-unquote recovery diets after the shows, meaning trying to eat more and regain body fat to recover, and then looked at the relationships between changes in their body composition and then metabolic and physiological changes. And in general, when you look at it, there's a couple of people who seem to succeed at actually quote-unquote reverse dieting. So for example, there were 2 of the males who managed to stay below 10% body fat 8 to 10 weeks post-contest compared to 1 week out. And there was also 1 woman who stayed right around 15% body fat, which was as lean as the other 3 women in the study got. So still very lean 8 to 10 weeks post-contest. And these 3 competitors, when you just look at the tables that I put in the study and when you look at the raw values, they really didn't have much of a change in terms of their leptin levels, their RMR, and basically they looked like they did not recover metabolically. Their energy expenditure didn't go up, and it went up really slightly in one competitor, went down really slightly in another, or stayed the same roughly in another. You saw leptin levels that either stayed the same or went up, but were still the lowest among the other women. And when you look at the group level, when you look at the associations, they're really strong between fat mass or body fat percentage and the changes. So for example, the Kendall's tau was 0.9, which is interpreted the same way as a Spearman's correlation or a Pearson's. So that's explaining 81% of the variation between the change in fat mass with change in resting metabolic rate. And it was 0.88 between the change in body fat percentage and the changes in leptin. So this is not, of course, a randomized controlled trial where we took people who got shredded and tried to stay shredded and other people who did it in a different manner and made conclusive statements about it. But it certainly seems that observationally, these people were attempting to stay shredded or stay close to it, gaining very small amounts of body fat, but increasing calories as much as they could. And it seemed that we simply did not see a return of metabolic health, at least in an 8 to 10 week period, while body fat stayed suppressed. So it actually fits the observations of what I've proposed here, that there does seem to be some effect of body fat levels when you're getting quite low that may not be present in the vast majority of cases where you're between your lower and upper intervention points, which is probably where the vast majority of athletes are hanging out, which is probably why it just hasn't entered into the vernacular of the REDS and low energy availability lines of research and those researchers, because it doesn't need to be. But when you're talking about getting to essential levels of body fat to get on stage, I do think you're starting to deal with a distinct scenario where you're pushing body fat levels so low that almost no matter how much you eat, which is going to be limited by not putting yourself into a surplus and then gaining body fat again, that your circulating levels of leptin are going to continue to fall back down to a point where these persistent negative adaptations that are going to make life kind of miserable, or at least make it more challenging to not be food focused, burning less calories and trying to eat more all the time, or fight the drive to eat more when you're getting really lean.
Yeah, I mean, I think you killed it with this one. You had a tough act to follow, being the second cover story in the history of mass, and I think you definitely stepped up to the plate and delivered a great one here. I was really stoked with this one that you mentioned, the dual intervention point model. I think it is such an elegant model for explaining and kind of contextualizing this particular topic. And one of the things that I find really unfortunate is, like, so Helms, you've been in the internet evidence-based fitness world for far longer than I have. I mean, how many times have you seen people refer to the set point theory?
Yeah, and I even have to say that I myself have even incorrectly used the terminology settling point, which is actually one of the models, but that I don't use the terminology correctly, just to describe that environment also plays a role. But yeah, most people talk about set point, and then they'll describe the other stuff around it that kind of gets at other elements of more accurate models, but they still stick to set point, and it's the common terminology for sure.
Yeah, I mean, within this little space, you'll hear people talk about set point theory, and they say, well, actually, we fixed it. Now we say settling point. And it's like, well, actually, what we're talking about here is probably more the dual intervention model. If we start to really kind of chip away at the exterior there and dig into what we're really referring to and what our expectations actually are in terms of body weight regulation. So if nothing else, I think this article was great because it brings more eyes to the topic of this particular model, because I think it's highly informative. And when I was first getting into this space, everyone was talking about body fat set points. And it was honestly a conversation that I kind of shied away from because I kind of felt like I didn't understand it well enough, because I was like, man, everybody seems really confident in this and I simply don't get it. Because I was like, I get what they're implying, but this doesn't really match my understanding of the world around me. But I assume I'm wrong on this. But no, I think the dual intervention point theory or that model is a really nice way to approach this problem. I love the way that you integrated all of these different topics and kind of cohesively put them together, because, research is siloed. So you've got, metabolic adaptation people or adaptive thermogenesis people like me, and we're over here in one camp talking about our crap. And then there's people all in that other camp who we, might, cross paths with them at some point, but they're over there talking about red S and they're talking about energy availability. And, there's there's even people who are way over there talking about exercise energy compensation, right? Compensating for calories burned during exercise. And there is this kind of cluster of adaptations that all relate to both acute and chronic energy availability. And I think there was a lot of need for somebody to kind of stitch some of these things together to answer a frequently asked question. I think you absolutely killed it and did a very great job doing that. And I'm hoping that people will walk away from this article with a much deeper understanding of what a realistic goal is for them in terms of how lean they should get, what they should expect when they start getting below their lower intervention point, and then making serious decisions about what they want to do long term. And the decisions are entirely their own. Some people might wish to try to maintain long term below their lower intervention point. That's an uphill battle. That's not the life I want to live. But for certain situations, certain scenarios, people might wish to do that. But the most important thing is people now, after reading this article, have the kind of conceptual framework and the understanding to approach that decision correctly and with all the information that they need. So I think that this article, aside from being well done, I think it's important. And I think that this is going to clear up a lot of misconceptions, because people generally know what it takes to get shredded and what that's going to feel like, or they at least have some expectation if they've never done it. But when it comes to that time after and switching to maintenance or reverse dieting and things like that, there's just so much uncertainty, and there are so many mixed signals that you get if you just read about it on the internet. And I just love what you did with the article. I think you did a great job.
Thanks, man. I appreciate it. And I think I'll close this out soon, because I know I tried to cover a lot, and I honestly think I did a far better job writing this out than trying to talk about it and connect the threads, because it's a lot to tackle in a 20-minute conversation or however long this is going. But I'll finish with, and what does this mean? What are the practical applications? And I think essentially it does come down to exactly what you said, is respecting your lower intervention point and being aware that some of the people who have strong motivation to stay below their lower intervention point, they are okay with living a life that you might not be okay with. So there was a article I reviewed in Mass not too long ago about female elite sprinters. And an interesting thing we noticed, or that was reported in that article, was that the individuals reporting more instances of symptoms of REDS and low energy availability, when you dichotomize them, they had slightly more body fat than those reporting less. And the way I interpreted that was that, hey, to be a really good sprinter, you have to be relatively low on body fat. It's just a matter of moving mass through space, and you have to accelerate it, overcome its inertia, and then maintain a high velocity to be a good sprinter. So if you have less body fat, which doesn't contribute to your ability to produce force, but does add to your total mass, you probably want that as low as possible without having negative effects that actually impede your ability to be a sprinter as well. So there are probably some people who just happen to have a lower intervention point who can happily walk around relatively lean and just live their life, while there are other sprinters who have to maintain a slightly weight-reduced dieted state with getting some of these negative effects, but not all of them, but whatever they consider is sustainable. And they're motivated by the reward of being an elite sprinter, and that's a sacrifice they live with. And that's probably similar in the fitness industry. Like, hey, I'm getting a lot of Instagram clicks. People are buying my programs. Do I need to eat a 3-gallon salad every night to feel full? Yes, but that's worth it for me, And that might not be worth it. In fact, it probably is not worth it for a lot of the people who are, following these people or, watching the Olympics and are interested in exercise, etc. So I think that's really important. And I can tell you with more than a decade of coaching under my belt that it will become relatively obvious after a few attempts. Typically the first time people diet, they do something extreme and they immediately smack themselves in the face with REDs. And then on top of that, they might also get lean and they're experiencing compounded factors of being below their lower intervention point. And then they come around the second time and they do it better or less disastrously. They don't diet quite as hard. They're not as restrictive, but they might notice, hey, I got leaner than last time and it wasn't as hard, but there was a point where it just became really difficult. And that's the experience of most bodybuilders who start more traditional and they eat the chicken and broccoli diet and they diet in 12 weeks and they switch to maybe going 24 weeks and having a more inclusive diet. And it's easier, but there's almost this inevitable point for most people where it just really starts to suck. And I think, I don't have proof, it could just be time spent dieting perhaps, or the cumulative energy deficit for people who might not agree with the way I've presented this. But what lines up with the models presented and the dual intervention model is that you're getting to a point where you're going to have compounded effects. So the take home is that you probably will experience some negative effects if you want to try to operate below that or far below that lower intervention point. But the hope is that, look, there is such a thing as an upper and lower intervention point, and most people are between them. So that means that you probably could maintain a leaner physique than you currently have, unless you're already, knee deep in all the evidence-based fitness stuff and doing a lot of things to modify your environment. But with, a lot of time and effort spent, and I am talking like, years of modifying your environment and changing your habits, there's no reason physiologically that you couldn't modify your environment to walk around a little leaner. And that is something that you'll see a lot of athletes and physique athletes in the off-season have done. And I think it might be worth the time and effort to do that. But just know that everyone does probably have a point where they'll be butting up against their body fighting back at them. And I think it's important to respect it.
For sure. And one kind of broader point that I'd like to highlight for readers and listeners is, you mentioned in this audio that you built a bit of a house of cards, but then you blew on it. You basically did some stress testing and said, does this seem to hold up when I compare it to the most relevant data available? And that's such an important step. And it's this continuous discussion that kind of inevitably will continue to happen time and time again. But within our space, you're going to see very plausible explanations for things where people say, oh yeah, I've got a handful of mechanisms. I'm going to stitch these together into a cohesive narrative that on the surface seems plausible. But the question is, can you take that next step and can you actually do some stress testing and see if that narrative, that house of cards that you've built up actually seems to withstand a couple gusts of wind. So I think, you did a great job highlighting the practical applications that are directly relevant to this topic. But I think even indirectly, this is a great opportunity to highlight what does it look like to kind of take separate bodies of research, stitch them together cohesively, and then do that very important final step of, take a look around. Does this seem to actually pan out? Does it seem to hold up? Because there's a whole lot of the first few steps happening out there where people kind of put together an understanding of how they see topics. But that next step of actually doing the stress testing is
in my opinion, by far the most important.
Well said.